Hey everybody, in this video we are going to start talking about something called the logarithmic function. And the logarithmic function is the inverse of the exponential. Without getting into too much of the history about this thing, we're going to discuss how it's relevant to us and where we're going to use it in the context of our course and our skill set that we need. Alright, so let me get started here. I've already made some notes. The logarithmic function. So it starts off by letting you know every exponential function, a to the x, that's greater than 0 and has a base more than 1, is a one-to-one function. We know that exponentials are one-to-one, and the horizontal line test shows us that. The inverse function of this exponential is called the logarithmic function. And this is the little definition that I've got for you here. And I don't want to get into too much more of the weeds with this. I want to come down and talk about the logarithmic function definition, because my videos get a little bit long if I get too wrapped up into that stuff. I want to show you how to use it and things like that. The definition of the logarithmic function says this: if a is a positive number, not 1, on the logarithmic function, base a denoted by log base a, that's the way you say that, is defined by, and here's the definition: log base a of x is y if and only if a to the y is x. So that goes both ways. And I'm going to show you the way this works in terms of application. It looks pretty confusing right out of the gate, but this is a very important property that we have to become good at using. I'm going to show you how to do that. But first I want to talk about the application of this and try to tie it to something you kind of already know about. And if I was going to do that, I'd say, okay, look, have we used inverses before? And I'd say, yeah, all the time. One of the most famous inverses we use all the time, if we consider our little function here, x squared, well, let's make him 1-to-1. And then we can think about his inverse function, which is the square root of x, right? And where we use that, solving equations. We'd solve equations like x squared is 5, right? We can't think of that number. We'd say, well, x squared equals 5 is solvable because we know that by this property of inverses, we take the square root of both sides. We'd say, okay, the square root of x squared is equal to the square root of 5. So x is actually the square root of 5. And then we'd go to our calculator if we wanted approximation, right? And if we didn't, we'd say this is exact. We could say that. Say, hey, this is an exact number. But I need a calculator or some way of finding out exactly what number times itself gives me 5. It turns out that it's approximately like 2.23606. Oops, that's supposed to be an O. 06 and then some more stuff. But I'm just saying that we got that number from one of our tools if we're approximating. If we want to leave it exact, we just leave it that way. But we know how to solve things that are squared. We invoke the inverse function and take the square root of both sides. And that's what we've always done. All right. With that being said, let's take a look at something else that we want to know how to solve. Right? And I'm going to break out one we already know. If I was told to solve the exponential equation, now your exponent is your unknown, right? And it was going to be equal to 8. We'd say, well, I might can manipulate this thing around and figure it out. Probably could. We'd say, well, 2 to the x is actually 2 cubed, right? 2 to the x is 2 cubed, so x must be 3. We can kind of just figure that out. We're saying 2 to what power gives me 8? 2 to the 2 is 4. 2 to the 3 is 8. We figured it out. Guess and check would do it, right? But eventually we run into somebody that we can't just do that with. Well, what about simple as the next number down, 7? Or the next number up, 9. You can't do that one either. So we say 2 to what power gives me 7? Well, we know it's not 3 because that goes above 7. That gives me an 8. Well, we know it's not 2 because it goes below. That gives me a 4, so that means that x must live between 2 and 3. X does live between 2 and 3 somewhere. And what I'm telling you that number is now with this new property is log. You got 2 to the power base 2 of the argument will be 7. That's the number you need to raise 2 to get 7. All right? So 2 raised to this power over here will give you 7. 2 to the x is 7. So that's the way this formula works. 2 to that power always gives you what's inside. So that's how you work these things out, right? Remember, the base is always the base. All right, let's go back here and take a look at some more of the definition stuff. That was just me starting to think about how this thing works. And we'll get a lot more in depth in this. All right, so in words, log base a of x is the exponent to which base a must be raised to give x. Yes, that's exactly what it is. Note, in blue here, we read this as log base a of x equals y, as log base a of x is y. Just make sure you say base a, because log a of x doesn't make sense. We need to know that a is your base. All right. So one of the most important skills we're going to run into is moving back and forth from exponential to log form and from log form to exponential form. And the way you do it is read them like I told you. A to the y is x. Just like that. A to the y is x. So 10 to the 5 is 100,000. And you work them circularly. 2 to the 3 is 8. And it's on this side. 2 to the negative 3 is 1/8. Now, when we deal with logarithms, you got to think of negatives as giving you fractions. A little bit different. So I got those for you. And down here, evaluating logs, log base 10 of 1,000 is 3 because 10 cubed is 1,000. And it's using this property to kind of move this stuff around. Okay? And this is actually 1/10, right? 10 to the negative 1 is 1/10. 16 to the 1/2 power. 1/2 power are roots. And I'll get into more detail about that in another video, because this one's going long on me. Okay, that's our intro. Look at these notes, study these notes, watch the video, look at the notes again, and I will show you how to put some of these in the calculator in the next video, okay? So I want to say this is our intro video only. There's no work that goes with this one, but we'll call this intro to logarithms. So we'll see you in the next one where we're actually going to do some work. Thanks for watching.